Um, it's really a pleasure to be here. For those of you who did not know, I used to be a student at CUHK. Actually, it was before CUHK, called Sun Ah. And my best friend during that day was Professor Li Tianming. We were not very good students, but we had a lot of fun. Anyway, like Helen, I spent most of my professional life on the development of human language technologies. Human language technology means enabling machine to recognize speech or synthesize speech or understand natural language and generate natural language or worry about modeling discourse and dialogue, these areas. So it's not a surprise, perhaps, that after being away for 10 years, helped to run the lab, I returned after the sabbatical in Asia to go back to human language, but trying to apply that to the problem of how to improve MOOC learning. I think it's really interesting. It's hard to imagine that it has been less than 4 years since the first course in MOOC was offered. In 3.5 years' time, we have really done a lot in this area. However, when you think about e-learning, I think we're doing a lot of E, but are we really doing a lot in learning? So I think this workshop is particularly appropriate at this time. So it's a bit like 战国时代, okay? Lots of nations are trying to fight out market shares. But fundamentally, I think we need to understand how a new way of interacting with students is going to help us improve learning. And I think this is what we're here to talk about. So I should say that the work is done with my student and Dr. Hongyi Li, who spent a year at MIT, and now he's a professor at the National Taiwan University, working in this area. So, so human language technology and MOOC, these two things are related because so much of our coursework, human language is a part of education, whether it's going to be textbook and slides or lectures or discussion, something to do with natural language. But what MOOC offers are two big challenges. The first one, in my mind, is heterogeneity. You know very little about the background of the people, and that background can be extremely diverse. You have high school students, you have retirees trying to do something, or someone in mid-career trying to change from one profession to another. Their learning style is different, their language is different, Chinese versus Indian versus European. And also, the preparedness is different. So it's very heterogeneous. If you're coming to CUHK, you're teaching a class here, you have a pretty good idea about the background of your students. And part of the challenge is how to deal with this diverse background for the students. And the second thing has to do with scale. You have heard a number of people talk about that. And you basically cannot have a one-size-fits-all type of way of learning. This is a direct consequence of the heterogeneity of our student body. What we need to do is to worry about mass customization, okay? It almost sounds like an oxymoron, but it is really true. You want to be able to customize for individual learners, and that's what we're trying to do. Now, human language technologies, I believe, could help. It could help us process and manage a large amount of content. You can do that. You can develop speech-based interfaces rather than typing or clicking. Maybe it will be easier for you to have a search engine that you can interact with using human language. But you really need to worry about how to develop general and scalable solution whenever it is possible. All right. So what are we talking about in terms of human language technologies application to the problem of MOOC? Many different things you can do. First of all, if the lecture is given in voice, what you really want to do is to be able to transcribe that. Currently, it is done by humans because if a course has 100,000 students, for example, you can afford to create a high-class transcription by asking people to type it in. But of course, there will be a delay between the time that you offer the course and when you have the transcription. You can do some machine translation, turn it into multiple different languages. You can do that, but it's a long-term research problem. Translation technology has advanced significantly over the last decade. However, it's not good enough. And if you want to use machine translation of the material, it better be as perfect as you can get. And you can worry about problems in language technology to do user identification and authentication. If you're going to offer a grade or a certificate, you certainly want to know that the person taking the exam is exactly the same as the person who registered to take the course, right? And then there is a very large area in terms of information management, how to characterize the information. If you have a discussion forum with thousands and thousands of entries, how can you tell? Put them into categories. These having to do with confusions on lecture 3, slide 17, for example. Or you want to say things that has something to do with the examination schedule, administrative issues. You want to be able to do that. And an area that I'm going to spend some time on is this issue of linking. How can you take different kinds of courseware and you try to combine them together, link together in such a way you can have easy access, for example. And then you have other problems in information management having to do with summarization. How can you say, give me a 5-minute summary of that lecture, or maybe a 15-minute summary, to be able to customize it to the people's needs? A sort of a computer-generated Cliff Notes, if you will. And finally, you want to worry about search. You want to make it easy for people to find the information that they need. Now, we are at CCEL, we're mostly spending time on these categories. So today, I want to show you some of the work that we are doing in this area. Now, before I move on to that area, I just want to reinforce something that you have heard a number of times today, but I want to do it with some data, okay? And the issue is that online and residential courses are different in many aspects. Now, Helen finished this morning's talk with a slide that shows there is residential education, there's online education. People who are doing residential education, like most of us, are a little apprehensive about that, right? Are we going to, if we pursue online education, are we going to basically work ourselves out of a job? But I think it's an interesting problem, and the way I would prefer to think about it is the same way that Helen is thinking about it, that at the moment, the flow of information and technology is one way. What we're trying to do is to say, okay, here are the courses that you're teaching on campus, and how can that be made into online courses? But in the end, the combination of e-learning and big data is going to inform us of the ways that it will benefit residential education. And you have seen some examples of that. So I wanted to show you a couple of slides, some comparisons. Now, we've been looking at between 25 and 30 courses being offered on MITx and also taught on campus. So the comparison is really nice if you have this many courses. So in particular, I want to focus on one course, which is Introduction to Computer Science. And people like to say this is a course about Python. And the interesting thing is that that course has been offered 4 times online. And we have data for 3 times on MIT campus. Furthermore, that's pretty much taught by the same professor. So we can actually compare these 2 things and try to understand. You know, we neutralize a lot of the variables. So multiple offerings of the same course at MIT and on edX. And then what we're trying to do is to compare those 2 courses in terms of many different dimensions. The class size, how many people actually drop out of the class, and the manner of interaction, the role that teachers play versus the roles that the peers play. And we find some interesting comparisons. Here's an example. On the left-hand side, we're talking about measurement on online versions of the same course and residential version of the course over here. Each one of these, this is one offering. This is the course costs $600. It's in the fall term of 2012, spring term of 2013, et cetera, et cetera. There are 4 offerings. Am I making myself clear? Okay. Now, here we have 3 offerings of the same course on campus. So you can look at this and you see, for example, the enrollment. You can see red is the total number of enrollments. That's measured in terms of tens of thousands of students. Whereas on campus, you're looking at 200 or 300 students. And this particular one is a high, the last time it was offered. If you look at the green one, that says how many people who actually passed the course, they were certified. You will see that on campus, the number of people who starts and the one who finishes are more or less the same. Of course, there are people who are dropping off, but not too much. Whereas if you look over here, compare the red with the green, you see a dramatic difference in terms of dropout rate, right? Another example, I'm just trying to make a few points here, is that if you were to look at this problem of threads, that is in the discussion forum, how many different postings of the thread exist? Then you will see that of these threads, the orange one that you have, how many of those were answered by the teaching staff, and how many of those were answered by your peers, your students, okay? On campus, you see, by far, a lot more questions were answered by the teaching staff, the purple. And here, so few were answered by the teaching staff, you can't even see it, okay, on this scale. Most of the questions were answered by your peers. So in fact, the interaction is very different. So it's not the case we can just graph the way we interact on campus and move it on to online, and in fact, these things are very different. You might ask, why is it that we have so many people dropping out? If you look at the marketing data, it says hundreds of thousands, millions of thousands of students have enrolled in a course. But if you were to look at it, looking at the data, honestly, this is the data provided by Professor John CUHK, who is the instructor for that Python course. And if you look at it, you will see that, in fact, this is the distribution. This is plotting how much time a person spent in the course, and this is a histogram, okay? So what happened is that this is actually the distribution of the students who finished the course, all right, and the amount of time they spent. And over here, the overwhelming, the gray ones are the ones who are, for whatever reason, started the course but didn't finish. Now you say, why didn't they do that? Well, maybe in the very beginning, somebody who spends a few minutes, maybe they're just shopping. They get into the course, take a look, and say, I don't want it, okay? And there are other ones who begin to spend some time, and eventually you see people using tens of hours, maybe here. This happens to be the piece that at least I am interested in. I want to say, if there is a way, maybe that's because they're not getting enough help. Maybe because their background is not sufficient. So what we want to do is to figure out ways to actually take some of these and move them over to the other side, as Chris has mentioned earlier, the distribution, okay? All right, so I'm going to spend the remaining time talk to you about a couple of things that we're doing in the area of linking. And this is the work done by one of my students, Daniel Lee. And the idea is to figure out ways of linking the material together. So what we are trying to do is to say the following, okay? We have all kinds of things, lectures and textbook and slides and all those things. Each one can serve, we believe, a reinforcing role. So if you can take all that information and try to link them together, so when you're talking about a given topic, you can link the appropriate segments of the textbook and the discussion forum, the slides, and the videos together. We thought this might be a good way of helping people, okay? So what we want to do is to link those things together and create sort of adaptive learning environment for students to navigate freely. So our hypothesis is the following, okay? It says if you can organize the courseware in a way that is easy for people to navigate and look for things, then perhaps it's going to improve learning. So today, the way we do it, the unlinked way, whether it's, for example, the red one might be the video of the lectures, this one might be the problem set, still other ones may be the textbook. They are basically organized as monolithic, independent pieces. And what we want to do is to move into this area in which, in fact, they are linked. For this particular topic in the lecture, the appropriate other kinds of courseware, sometimes you have more choices and other times you have less, are linked together. The hypothesis is that if we do this, it's going to improve learning. And to put it concretely, what we're trying to do is to build two types of interfaces. In one case, the video, the books, and other things are done independently, presented to the user independently. And in another case, things that are related to, are linked together. So at the same time, they're at your disposal. You can find the information and presumably learn more. Now, learning is a very hard thing to measure. And what we're trying to do is to think about sort of derivative, the properties of learning. And what we would like to do is to say, if we present interface 1, unlinked, compare it to the linked method, we want to measure how well people can look for information, for example, when they're doing a problem set, and how well can they recall the information, the concept retention. These are some of the problems that we're asking ourselves, okay? So could it really help? And what we're trying to do is to conduct a crowdsourcing experiment. You have heard Rob Muller talk about that, so I won't elaborate. So what we're trying to do is to take a course. In this particular case, we look at a statistics course from UC Berkeley. And it has videos, it has slides, it has textbooks, and this kind of thing. And what we're trying to do is to use the Amazon Mechanical Turk, the micro task workers, to be the subjects. And they have varying backgrounds. Some people have college degrees, some people don't have college degree. Some people have taken MOOC before, and some other people have not. And some have taken statistics before, and some have not. Okay? So we were doing in an experiment. It says, well, if we can link it, would it make any difference to these subjects? And the ground truth is actually done by human experts that link them together. But since then, we have created automatic techniques to link these things together. At the moment, we want to know the best possible consequences. And we measure information search, how fast and how accurately can you look for information. So you say, doing a homework problem, you need to know about regression in statistics. How fast can you find the information? And then concept retention, you say, well, this segment, please summarize it. And we try to measure how many things that we taught you that you can actually recall, for example. Again, the whole bunch of things that we talk about, I just want to pick one to show you. And so here's one that has to do with information search. You ask the person to retrieve a piece of information after they have taken the course. And here is an example. Let me explain this plot for you. Remember, I have two different interfaces. One is unlinked, all right? And here is linked interface, and I'm asking people to retrieve the information. The idea is if linking really helps, it's going to be faster, right? So I take the amount of time that you will use to look for unlinked, subtract the time that you do to solve the problem by the linked interface. And if that number is positive, it provides indication that, in fact, it's good. All right? So overall, we found that in the tasks that we provide to people, they do it maybe 40 to 45 seconds faster on the average across all the users. Now, here's what's interesting. We have these three categories: people with some college degree and some not. And so what we have is differences between these two, and we can measure sort of the statistical significance of that. I think the check mark might have been in the wrong place. No? Yeah. This is people who, with a college degree already, this is the more novice part of the population. People who never taken a MOOC course before. And the significance is statistically, the results is statistically significant. So what it appears to be the case is that linking will improve the speed in all cases. And I haven't shown you the accuracy. It turns out the accuracy in both conditions are about the same. So it gives some evidence of the fact that if you can link the data together, and a number of speakers before me have talked about that as well, that it would help the novice users. So those people, remember I said we want to move it towards certification. They want to complete the course. We want them to succeed, and I think linking might be one of the answers, all right? So as I mentioned to you before, since then we have done some automatic means of taking the course material and try to link it together, and we have some very good results. And the improvement, the most important thing is you didn't sacrifice accuracy, all right? Okay, so let me change the topic into a different kind of linking. And this has to do with linking courses from different places. Let's say in edX, you can have a course on machine learning taught at Berkeley. You have a course on machine learning taught at Columbia University. And maybe one lecturer will explain things better than the other lecturer, for example. So what we want to do is to be able to say, take a bunch of courses that's coming in, and you want to link the courses and find out across different courses what, say, you want to learn something, a concept like regression. You want to see how this teacher will teach and the other teacher will teach it, so you can link the material that way. And also, you can actually, based on this, be able to figure out what are some of the prerequisites. If I'm confused, I want to know how far back I have to go to pick up the necessary background information. If I'm bored because I already learned this information, how I want to move on to the next level of more advanced material. So this thing is done in about half a dozen steps, and I will quickly go through it with you, okay? The first is to gather the data. You take all the course material across not only different universities, but different platforms. In fact, this thing I will show you later, we take a Coursera courses and edX courses, and we can deal with that simultaneously. Collect the video clips and collect the MOOC across different MOOC, and that's the first step. The second step is we try to extract automatically the key terms in each one of those lecture vignettes, if you will. And based on the audio transcription and different kinds of things, for example, one of the things we do is to tag automatically the parts of speech for these cases. And then we pick out the nouns and noun phrases and consider them to be candidates, all right? And then we are going to filter by some lexical statistics. For example, in our case, we were using TF-IDF, term frequency, inverse document frequency type of measurement. Once that is done, we get a bunch of phrases, for example, for a computational biology course. The third step is you begin to extract the relationship. And what you want to do is to be able to form the relationship based on these kind of concepts. So if the transcript said the DNA encodes RNA it is the material of inheritance. So this pronounal inference, you want to change it to co-reference and turn it into a DNA. Okay? Just converting the pronoun into its reference. Then you do some syntactic parsing of these sentences, come out with the parsing of the sentence DNA is the material of inheritance, for example. Then what you want to do is to say, I want to extract the relationship between these entities. And so what you can do is to say these two things, DNA and inheritance, are related in some way. And the way we want to find that relationship is using a statistical model. In this particular case, for those who are interested, it's called open information extraction. Okay? And once you do that, then you can say that's the relationship between two entities, and we can figure out the relationship. All right? The fourth step is to create something we call a knowledge graph. Once you have these entities there, and you can figure out that DNA and inheritance, one is the material for inheritance. And then for DNA, all these links you generate automatically, creating something we call a knowledge graph. Okay? Two more steps. Then what you want to do is learn what are the prerequisite concepts for a given entity. What does that mean? Sometimes if a person say, I am lost, we're going to say, oh, let's move on, review some of the material so that you can move forward. So the way we do that is to actually try to figure out the relationship. And here, let's use these two examples, okay? So what you're trying to do is to say, all right, DNA happens to be first introduced in lecture 3, whereas the idea of inheritance was first introduced in lecture 1. And therefore, 1 is the background material from lecture 1 for 3. So inheritance is the prerequisite. Similarly, if you were to look at DNA and RNA, this is first done in lecture 3, this is done in lecture 10, so this must be more advanced material. And we can figure out this kind of relationship, okay? All right, so then you do this whole thing for different courses, maybe one at Berkeley and maybe one at Columbia or MIT and Stanford. And what you really want to do is to use this technique in natural language processing called vector space models. And that's basically a way of representing a paragraph, if you will, in terms of a vector. A vector consists of the different terms, and you want to be able to do that. And whenever two of the courses, two pieces are very close in terms of similarities, similarity as measured by something called cosine similarity, then we can link them together to be able to do that, all right? So that's pretty much it. And later on, if somebody say, I don't understand DNA, then you can say, well, maybe you should look for something about the lectures about the prerequisite. If you say, I know this already, tell me more about other things, then you will figure out something else. So I don't know whether I'm going to be successful in playing this video. If not, I have to do that. This is a 1.5 minute video. Would it work? Huh? No sound?
Many courses available on the internet using different platforms such as Coursera and edX. If a student wants to learn something about language models, for example, he or she can type a search query.
Sorry, I'm going to start from the beginning.
The increasing popularity of massive open online courses, or MOOCs, has resulted in many courses available on the internet using different platforms such as Coursera and edX. If a student wants to learn something about language models, for example, he or she can type a search query into the lookup window and receive several course suggestions. However, there is no easy mechanism for the student to determine how the courses are related and which one to choose. The problem is even harder if one wants to search across multiple platforms. Cangjie is a tool developed at MIT to help students taking MOOC courses to visualize the relationship among many courses from multiple online MOOC platforms. By linking these materials together and presenting them in an intuitive interface, Cangjie can potentially help a student customize their learning environment by choosing the suitable learning path, reviewing background materials, or skipping ahead to more advanced topics. The linking is achieved using human language technologies. In this demonstration, after a student types language model into the lookup window, Cangjie returns two related lectures from Coursera, one from Stanford and one from Columbia, each highlighted in a different color. The student can retrieve the material by clicking on the corresponding node.
Okay, so the first topic we're going to cover in this course is the problem of language modeling.
Through automatic linguistic analyses of the transcriptions of the lectures, the system can organize the lectures from these courses into a single map by linking the lectures on the same or similar topic marked in red. For this example, it is clear that the course materials for the two are quite similar for the first several lectures before they diverge. By clicking the red nodes, the student can compare the two courses on the same topic side by side. In the next example, the student is interested in learning about Python. Cangjie returns 3 courses across 2 different platforms, edX and Coursera. The colored nodes show the various combinations of the 3 courses. The final example highlights Cangjie's ability to help a student create a customized learning path. A student interested in learning about DNA can type DNA into the lookup window. Cangjie then returns several related courses across multiple platforms. The system also links the input key terms with their prerequisite concepts, shown on the upper left. By clicking Inheritance, the material related to inheritance will be displayed for the student to review. By the same token, the student can skip over the current topic and explore more advanced topics suggested in the upper right. In this example, the student clicks RNA and the corresponding advanced material will be shown.
Okay, my time is almost up. So I would just say that we're working on a number of topics at Spoken Language Systems Group. We have already mentioned the automatic content linking. We also are doing some work in topic modeling, video processing, and also in sentiment analysis. So in summary, what I am trying to say here is that we have done some work in the area of applying human language technology to the problem of MOOC. And we have got some interesting results, improvement, extensions, and all those kind of things are ongoing. And we're very interested in finding people, like-minded people to be working on this, and so that we can achieve impact. Thank you.
Thank you, Professor Xu. We will now have a Q&A section. May we invite Professor Helen Mang to host this section for us?